Good morning, boys and girls. We are going to be working on Chapter 13, Lesson 7. This is on area and the distributive property. And you probably remember that the distributive property is about how you can decompose or break apart one of your factors and multiply the two addends by your second factor. It makes things a little bit easier when you are multiplying, especially when you get to bigger numbers. So follow along with the lesson, and we will go from there. All right, so just to start, we'll do our problem of the day. And this one's an easy one. So it says to find the area of this rectangle. And so there are two ways that I can do that. The first way I can do that is by counting the squares. 1, 2, 3, 4, 5, 6. So the area of this rectangle is 6 square units. I can also think about multiplication. And so the length of this side is 2, and the length of this side is 3, and 3 times 2, or 2 times 3, also equals 6. So whichever way you do it, you're going to get 6 square units. So the area of this rectangle is 6 square units. Whenever you are coming up with your answer for area, remember to always use square units, whether it's square units, square meters, square inches, square centimeters, whatever. When you're finding the area, you're always going to answer in square units. All right. So next, let's move on to our lesson. So we have a green rectangle here, and you can follow along in your book. This is page 791 if you want to follow along. So we're going to look at this green rectangle, and we need to find the area of this rectangle. So let's try the two different ways. We can count the squares. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So I came up with 30 squares, or 1, 2, 3, 4, 5, 5 times 1, 2, 3, 4, 5, 6, 5 times 6, I'm still going to get 30. So regardless of how you do it, you're going to get, whoops, I don't know what that is. No matter how you do it, you're going to come up with the same answer, which is 30 square units. Okay, so we want to label this green rectangle A. So you can label it A in your book too. Okay? Now, what I want to do next is I want to shade more unit squares so that the length of the rectangle is now increased by 2 units. Now, the width is going to stay the same. So what I need to do is I'm going to increase the length by 2 units. Okay? And I am going to label that rectangle that I just added with rectangle, I'm going to name it rectangle B. Okay, so my green rectangle is rectangle A, and then my added on rectangle is rectangle B. I need to find the area of rectangle B. Well, I can do that both ways. I can count the squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or the length here is 2, and the length here is 5, and 2 times 5, or 5 times 2, is 10. So the area of rectangle B is 10 square units. Okay, so make sure you've got all that filled in. All right, the next step is to use the distributive property. And you can see in step 3 here that that's exactly what they did. They distributed 6, 2. It was 8. It did have a length of 8. And it distributed it, the green was 6 times 5, which was 30. The pink is 2 times 5, which is 10. And then when you add those two numbers together, you get 40 So this new rectangle, the larger rectangle, rectangle A and B combined, is 40 square units. All right. So here it says that the distributive property can be used to model the area of a rectangle. Recall that the distributive property allows you to decompose one factor. And why that's helpful is because when you break apart that one factor, usually the larger factor, it's just going to make your calculations a lot easier. All right, on the next page, so now we are going to be looking at page 292. So if you're following along in your book, make sure you are looking at page 292. And we are going to use the distributive property to find the area of the rectangle. So the rectangle that we have is 12 units across the top and 7 units across the side, okay? We want to decompose this rectangle. So we're going to decompose it into a 10 plus 2. So it's still going to be 12. It's still 12. We're just decomposing it so that I'm going to draw this line a little bit bigger so you can see it. So now I've got 7 units times 10 units and 7 units times 2 units. Okay, so all I'm doing is decomposing that rectangle, so it's just going to make it a little bit easier for me to work with. Okay? Oops, my line moved. I'm going to redraw that line here. There we go. Maybe you can see it better now. All right, so I'm going to take this rectangle, this large rectangle that I've now decomposed into 10 units in 2 units. So this is going to be like our rectangle A. This whole big rectangle is rectangle A, and then we'll label this smaller one rectangle B. That's kind of like the first example that we did. So if I'm just looking at rectangle A, I'm going to be either counting, I could totally count here. That's just a lot of squares to count, and I know I can use multiplication to do it. So I'm going to multiply 7 times 10. And I think, oh, I know my tens. 7 times 10, that's easy. That's 70. Those tens are those facts that we know pretty well. Then I'm going to look at rectangle B. So that's going to be 7 units times 2 units. Well, I know my 2's really well, too. That 7 times 2 is 14. So then when I add these two together, 70 plus 14, I get 84. And you can go back and look at your fact table and double check that. Does 7 times 12 actually equal 84? And when you check it, you'll find out that it does. So we know that the area of this larger rectangle is 84 square units. So now let's take a look at the talk about it section. And in class, we would normally just talk about it. We wouldn't necessarily really write anything down here. But since we aren't together, we can write it down. So we're going to refer back to that second activity that we just did with that rectangle that was a 7 by 12 rectangle. We decomposed it into 10 and 2. Made it a little bit easier for us to solve. So here it says if you decompose that 12 into 9 and 3 instead of 10 and 2, what would happen? Would it have the same result? Remember, our result was that that rectangle had an area of 84 square units. Well, we decomposed that 12 into 10 and 2 to make things really easy for us. But let's try it this way. Instead of decomposing it 10 and 2, let's decompose it 9 and 3. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm just going to draw I'm basically just shifting my line over 1. So now rectangle A is here and rectangle B is here. Okay? And so now I've got 9 times 7, 9 times 7, and 7 times 3. This is a little bit harder because I don't know my 9s and 7s quite as well as my 10s. But if I look at my fact table, I can see that 9 times 7 is 63 square units. And 7 times 3 equals 21 square units. And then if I add 63 plus 21, well, look at that. I still get 84 square units. Okay, so it doesn't matter how I decompose it. Decomposing it with 10 and 2 just made it a little easier because I could use mental math a little bit easier without really having to check my fact table. You might want to use your fact table just to check yourself, and that's fine too. All right, so for number 2, it says, how can the distributive property help you find the area of rectangles with greater numbers? Well, the distributive property helps me because then I can decompose the greater number into a sum of smaller numbers. And then what I can do is I can multiply the smaller numbers and add the sums. Okay. All right. So next we're going to start on the practice. And you're going to do this on your own. Try number 3 on your own. I'll give you a minute, or you can pause the video. All right, so here I have a 7 by 6 rectangle. It's got 7 units across the top and 6 down the side. And I'm going to decompose the 7 into 5 and 2. So like this. So then I have 5 times 6 here, or 6 times 5 here, which equals 30. And then I've got 6 times 2, or 2 times 6 here, which equals 12. And 30 plus 12 is 42. Double check your work and see if you got 42 square units. All right, Next, we are going to use the distributive property to find the area of this rectangle. So I have 9 units across the top and 8 units going down the side. So I'm going to decompose that 9 into 5 and 4. So work through this problem on your own. Pause it, pause the video, and then try it. All right, so 8 times 5 is 40. 8 times 4 is 32. 40 plus 32 is 72. So the area of that larger rectangle is 72 square units. All right, here we don't have any squares. We have to use the distributive property to decompose the longer side into a sum. Now, it does say to show the steps that you use to work it. So look at exercises 3 and 4 as your examples. That's how you're going to show the distributive property. Here, you can do it however you want, but I recommend doing it in a way that you're making things easier for yourself. So if I look at this rectangle, it's 11 centimeters by 4 centimeters, and I do need to decompose the longer side. So I need to decompose the 11. I'm going to make it a little easier, and I'm going to decompose it, and it doesn't have to be perfect where you draw your line. I'm just going to decompose it right here, and that's going to be 6 centimeters and 5 centimeters. So I'm decomposing that 11 into 6 and 5. So instead of 11 times 4, I'm going to be multiplying 6 times 4 plus 5 times 4. And that's how I'm going to do the distributive property here. 6 times 4 is 24. 5 times 4 is 20. Add them up, and I get 44. 44 square centimeters. You could decompose 11 however you want. I just did it with 6 and 5. You might have done 7 and 4 or 10 and 1. However, whatever works for you is fine. For number 6, we need to decompose the 12. I'm going to make things really easy for myself because I know my 10s really well and I know my 2s really well. So this length is going to be 10 and this length is going to be 2. So instead of 5 times 12, I'm going to decompose it and have 5 times 10 plus 5 times 2. 5 times 10 is 50. I know that. 5 times 2 is 10. Add them up. 50 plus 10 is 60. So the area of my rectangle is 60 square